Hello and welcome to this month's FDTD Satellite Applications webinar. Today we're very happy to have Brandon Eidlet, a meteorologist from the forecast office in Guam, where the National Weather Service Day begins. Brandon is a North Carolina native, went to NC State, then jumped into the Pacific Ocean at Quaj, and then moved a little bit farther west to Guam in his career. So you can deduce from that the direction that he's moving westward through his life. The talk today is operational use of scatterometry in an otherwise data-sparse tropical Western Pacific. Just a few notes about logistics. If I can get to the next slide. This is an ongoing webinar series. There is a website that you can go to view all the past ones. They're all recorded. We're always looking for speakers. So if you know of someone who wants to speak on a topic, or you yourself wants to speak on a topic, please get in touch. About 20 minutes for the speaker today. We'll follow that with some Q&A. You can enter the questions by GoToChat. Don't press hold. Mute when you're not speaking. And that's all I have. And we're gonna let me make Brandon the presenter now. Let's see, make presenter. Take it away, Brandon.
All righty, so I see this option to show my screen. So, all right, so good morning, everybody. It's great to be here. Thank you for the introduction, Scott. And so I'll tell you a little bit about the Guam region, the whole Northwest Pacific Ocean. So a little bit about our area of responsibility. Here's a picture on AWIPS. You can see the Alaska region, the continental US, and out across the Pacific Ocean. The Northwest Pacific Ocean is a massive area that for Guam, we provide forecast and a 24/7 weather watch looking for tropical cyclone development across an area that's about 4 million square miles. That encompasses the territory of Guam, the CNMI, which is the Saipan, Tinian, and Rota, 3 islands just to the north of us. We also have the Republic of Palau, Federated States of Micronesia, right across through the middle, and then also the Republic of the Marshall Islands. So we have 3 different countries within our area of responsibility. When we look at that and consider what kind of data that we receive, well, we've got thousands of islands across the region, but very little data. In fact, we have 11 airports that we provide forecasts for, and only just a few surface observation stations provide 24/7 observations. Many of the airports, they stop reporting observations overnight, so we're limited in that regard. But when you look at the radar coverage, we have only 2 radars across the region. One is the Army base, where I was employed before the National Weather Service office here on Guam. That is in Kwajalein. And then, of course, we have the Guam Weather Radar, which is under repair right now, so not currently operating. Now, I know mesoscale models are a big thing stateside. We only have the advanced high-res WRF just for the Marianas, just a very small sector of our broad region. But what can we do to fill in that gap? Satellites come in very handy. Out here we have the geostationary satellite, the Himawari, that is with the Japan Meteorological Agency, but also of just very much importance is a scatterometer. So if we look at a 24-hour day coverage of scatterometer, we'll just sequence through and just see how much data the scatterometer provides. Now, the way these the data plots are populating, this is not the way scatterometer comes in on a daily basis. I am just doing it in this order just for dramatic effect. But on a 24-hour basis, the ascending and the descending scatterometer passes cover a broad swath of our region, providing very important data, especially in areas where we're expecting to see tropical cyclone development. Up here to the northwest of the Marianas, we're not so concerned unless there's a marine implication. but down in the lower latitudes between the equator, 10, 15 north, we have much more concern, obviously, for any threats to our islands. And now I mentioned earlier, we have the ascending and descending passes of the scatterometer. For me, I look for the D in descending that references the local daytime. So wherever you are around the world, the descending pass is roughly your local noon, and your ascending pass is your local midnight, give or take about an hour for the processing. The data will populate from right to left, from east to west. Now, there's a couple of different scatterometers, and they have different scan strategies. The more familiar for us that we use on a daily basis is the ASCAT, and it has several sensors that will scan to the left and to the right of the satellite track. And then you have some other sensors that have a rotating sensor that provides a much wider full data coverage because it is spinning around in circles versus the ASCAT, which is looking on to the left and to the right at roughly 90-degree angles in the course of an entire pass. Some things to keep in mind with scatterometers: very weak, very strong winds, the data becomes less reliable. So in clear air without rainfall, you're looking at reliable data as you're getting above 5 knots or so. But in the very calm winds of a subtropical ridge or a trough axis, those wind speeds may be a little bit unreliable. However, on the other side of wind spectrum, stronger winds that you see typically with tropical cyclones along frontal boundaries sometimes, especially where there's rainfall contamination, those winds become unreliable, especially as you start exceeding 45, 50 knots and heavier or stronger winds. Now, heavy rain will also distort the signal because the scatterometer is looking at the surface, the sea surface conditions. It's looking at the effects of the winds on the sea surface, those capillary waves. If you have relatively calm winds, heavy rainfall, that really distorts the water surface, and the scatterometer sensor will see that as faultily stronger winds. Sometimes you see incorrect wind directions. That is because of the ambiguities. There's usually several solutions, at least 2 solutions for the wind direction, and with a little bit of input from models, those wind solutions can be used to pick the right ambiguity. And so it's always best when doing analysis with scatterometer data to use real-time satellite imagery to go hand in hand to get a full informed idea of what's going on. So here's a circulation in the Gulf of Mexico back on May 21st. And you see some of those black wind barbs highlighted. Those evidently don't make sense. In a counterclockwise rotating circulation, why do you have these winds pointing in the opposite direction? That's just an improper ambiguity selection. Those black wind barbs, that indicates heavy rainfall, and that's kind of distorting the signal. So we're getting a rain flag. So there's possible rainfall contamination in that area. In the bottom image, you see the ambiguities, and where you see straight lines, that's actually 2 solutions. So the key is something like this. The way to interpret those ambiguities is from a center point, the implied wind direction is either heading, in this case, to the north or to the south. It's flowing out from the center point. Now, where you see just straight lines, you've got a pretty good choice and a pretty good idea of what those wind flows are. But then where you start seeing some crosshatches, some X's, T's, or Y's, there's more choices, and probably you might see a higher potential for some improper ambiguity selection. And of course, this is one of those light wind patterns. Now, for our operational use here in Guam, we rely very heavily on the scatterometer for many different aspects of our forecasting. First of all, with the ascending and descending passes, we do a surface analysis every shift. We're looking for the different weather-making features. We're identifying their location and their relative size and magnitude, and we compare those to the model initialization. Sometimes the global models do not do so well with formative stages of tropical cyclones and other weak equatorial disturbances. We're also looking for trend assessments versus model timing. Right now across the West Pacific, we've got a large tropical cyclone well to the northwest, a monsoon trough to the north of us, and we've been looking in the forecast, 2 to 3 day forecast, for another circulation to form over the far northern Mariana Islands, about 600 miles to the north of us. The implications is if that circulation does develop, we could see a drastic increase in southwesterly monsoon flow across our islands. That would have implications with surf, small craft advisories, intense heavy rainfall, and strong gusty winds. And right now, yesterday, July 21st for Guam, that was our Liberation Day, celebrating 77 years since the liberation from World War II, Japanese control. And so there's been a lot of outdoor ceremonies right in the time of these monsoon southwesterly winds. So having proper forecast that is well informed by the scatterometer data is key to really informing our decision support partners. Now, we also use the scatterometer data to provide a better assessment for hazardous or near hazardous marine conditions. Additionally, considering the wave models out here in the Northwest Pacific, we do see some weak tendencies in some of the wave models, particularly the global wave, and underdoing some of the long period northerly swell. These are swell events that originate from frontal systems that come off the coast of Japan. While the model will indicate 2 to 3 foot swell, we often see 5 to 6 foot swell. We have some nomogram marine charts that we can assess the scatterometer based winds. We can look at the fetch width, fetch length, and the average wind speed based on the scatterometer data. And we can calculate the size of a swell, the arrival time of that swell, as well as the swell period and swell height. And we often see some really good information coming out of that sometimes excels what we see in the model data. Also, case studies. Every so often, we rarely see severe weather across the tropical Pacific, but there are those cases where we do see some hazardous conditions, and scatterometer is a fantastic way for identifying those hazardous wind events that will key us into looking into other model and satellite data to really piece together what happened. So recently, we've had a tropical depression form over the Philippine Sea. Now, just for your bearing, here is the island of Taiwan, the Philippines, and the far western Pacific. The Marianas, the Northern Marianas, there's Saipan of the CNMI, a Commonwealth of the Northern Mariana Islands. Guam would actually be right about down here in the blue. And so we see these stronger winds. This is part of the southwest monsoon. And then there's a circulation somewhere around here, a string of circulations looking at comparing with the visible satellite imagery. How do we determine this depression was centered right here? That was the help with the animated satellite imagery. During the daytime, visible is ideal, but even in the nighttime, I find the shortwave IR for the Himawari satellite, it would be band 7, 3.89 micrometers is very useful for cutting through some of the cirrus clouds and seeing some of the low-level cloud motions. However, there are some other scatterometers that are quite useful. There's a Chinese scatterometer, the High 2C, that has a wider scan pattern. Remember that rotating beam? This one has a much wider coverage and will sometimes show you the information that you're looking for. Now, these green barbs, that is the model-based, the European model winds for that time frame. And so that shows you a comparison of what the European model shows versus the scatterometer. So in this case, you see this one wind barb that is a little bit angled from the European. That one is probably the closest ambiguity, scatterometer detected wind direction. And so it's using the European model to inform that selection of a wind direction. And you can roughly see the axis of the surface trough and the center of that tropical depression. Now, this was a surface chart that we had back in June. And so what we like to do is we composite both or all three of the ASCAPs, A, B, and C, to get as much data onto a map. So you see these gaps. A, B, and C at this time of June were pretty much over top of each other. The scan tracks overlap, and you can see a little bit of overlap in this darker shading, the way we kind of stitched them together. There's a little bit of orbital drift between the METOP A, B, and C satellites, and there was very narrow gaps back in October. The gaps increased as the scan swaths kind of overlapped, but now we're starting to see increased data coverage as the satellites continue to kind of drift within their orbits. Today, you can see the width of those gaps are much narrower. So this was this morning's surface analysis, the midnight analysis. Mariana's right here in the center, and now that tropical depression is a full-blown typhoon approaching Taiwan, and we have a monsoon trough extending kind of off to the east. And then we just have brought several disturbances along Micronesia that were really, it's giving us a complex forecast as there's a lot of model spread. Just where will this another circulation form to our north, and then how much of these southwesterly winds are going to just pull right over the Marianas. Right now, we're looking at the far northern islands will be under the heaviest showers. So case studies are immensely helped with scatterometer data. This is the circled island. This is Chuk Lagoon. There's a number of small islands within this lagoon, and very small civilian structures, no concrete structures. Out here on Guam, we're used to typhoons and earthquakes. All of our structures are solid concrete. Across Chuk and much of Micronesia, substandard buildings and not very resilient to strong winds. Additionally, much of the commerce and transport is done on small boats. In this case, just a couple of days ago, we had a significant wind event approach and move right through the Chuk Lagoon. It brought their airport observation indicated 30 to 34 knot gust, and we actually had a few reports of some sunken boats that people had to swim to nearby islands to get ashore. And sometimes the global models do not handle these events very well. They will show some stronger winds moving through, but often they are lacking in the magnitude of some of these wind events. So seeing this data come in real time is absolutely vital to getting the word out to the islands across the region. And just for example, here's some pictures from Chuk. Calm waters, but a lot of islands that people had to take small boats. They load those boats very heavily. So just imagine how deep those boats sink with their full loads. And then you get a little bit of wave action from those stronger winds, and those boats start taking on water. And then you've got a lost battle on your hands. Now, across the international date line, here's another one of our forecast points, the Majuro Marshall Islands. And the international date line, New Year's Day, there was a massive wind event across just in the open waters. This did not affect anybody, but it was initially visible through the leading gust front outflow boundary from deep convection that had kind of collapsed. And then you're left with these mesoscale stronger winds. This would have been pretty bad had it affected Majuro, where many people live in very crowded lean-to shacks, a lot of plywood and sheet metal, and that stuff can be very hazardous in such winds. The 50-kilometer resolution, we're seeing 35 to 40 knot winds, and I can guarantee you at the 25-kilometer resolution, you're going to see some stronger winds at the surface. Out here, we do use the coloring to highlight some of the marine hazards. We have our thresholds for small craft advisories set at 22 knots, and that roughly corresponds to where you see the yellow winds. So we don't have any forecast points for this part of the Marshall Islands, but right here at Majuro, we'd be strongly considering a small craft advisory and this dry trade wind pattern. Now, some other sites for scatterometer data. This is probably what most people are familiar with. This is the star page. This is Manati Nesdis. Some people say Manati, others say Manatee. This is where you can see the scatterometer METOP A, B, and C. and you've got the nighttime pass and the daytime pass. There's also a few other scatterometers, the SMAP, the GCOM. Those only provide wind speeds. And so here's a SMAP representation, and then also the GCOM. These are useful for at least identifying the areas of weaker and stronger winds. You can identify subtropical ridges, troughs, frontal systems, just by the nature of the wind speeds. Additionally, there is the synthetic aperture radar, the SAR. This is very high resolution wind data that is very nice to be looking at tropical cyclones. And you can actually look at several years of the past several cyclones in which the SAR data was able to get some good captures. Now, this data is very high resolution, so you don't have very wide data passes. And this data has to be configured ahead of time. So for most of us, we're not going to see this data in real time, although the Joint Typhoon Warning Center and I believe the Central Pacific Hurricane Center and the National Hurricane Center get this data more in real time for decision making. Additionally, there are some nice visualizations. The Brigham Young University, you had to go onto the under the additional products, click on storm, your year, your oceanic basin, and then you can select your storm name and scroll down this long list, and you eventually see some of these post-processed images that color code the wind speeds. This is very nice for identifying some of your wind hazards based on wind speeds. It helps you better determine the timing of maybe some of your watches and advisories, onset for winds, or even dissipation of winds. And here at WFO Guam, we actually issue our own tropical cyclone watches and warnings. So this is very useful for us to really see what the wind timing and the scope of the winds are. And then, of course, there's also another site within NOAA, the NOAA Office of Satellite and Products Operations. This one provides only the A and the B scatterometers, but this one seems to be a little bit faster than the Manatee site. And then also the Netherlands, they have their scatterometer page. This is a multi-platform product viewer where they can composite many different scatterometers. You have the ASCAT A, B, and C for the METOP satellites, SCATSAT 1, which is now no longer operational, High 2B, 2C Chinese satellites, and then the CFO SAT, which is a partnership with the French and also the Chinese. And so you can see a lot of different scatterometer data in the past several hours. And with that, I will go ahead and conclude. I want to say a special thanks to Scott Lindstrom. I've learned a lot from him in the past several years. He's been very willing to answer a lot of my questions, not only about scatterometer, but about the GOES and also the Himawari satellites. And I appreciate his time and willingness to always provide answers in very short turnaround time. Also, Roger Edson, the SU here at WFO Guam, he is a lifetime microwave satellite scatterometer expert, many years and working with scatterometers, microwave imagery, and tropical analysis. And with that, are there any questions?
Thanks, Brandon. That was great. And I have a question.
Okay,
so I noticed a lot of your scatterometry plots were hand analyzed, meaning
Yes.
that you're printing them out. I can understand why you do that. I'm wondering if you ever view this in AWIPS so you can overlay it on top of the satellite imagery. I mean, it sounded like you're doing kind of that, but is that something that is that an AWIPS capability in your office?
Yes, so we do get the ASCAT data within AWIPS, and that through AWIPS is actually the fastest way to get it in. So usually toward the end of my evening shift, I get off at 10 p.m. I'm able to pull in probably half of the region scatterometer to really get a good look at that to populate, to use for our airport TAFs. And so that comes in very handy. We've actually had our AWIPS focal point kind of reassign the colors to better align with some of our hazardous conditions. In addition to printing off the scatterometers, For a long time, we've used Microsoft Paint to composite those, but we've actually got a couple of new forecasters now who have some scripting background and have actually created some scripts that will automatically go to the websites, pull them out and put them together. So all you've got to do is print them out. But yes, to answer your question, we do get the scatterometer, and we often do overlay those with our satellites.
Thanks. And I'll also add that there is an effort underway now to get SAR data into AWIPS. So it's just starting. So at some point in the next couple of years, maybe that'll show up as well.
That will be fantastic. We look forward to that.
I'm going to see if I have any other questions. Let's see. I see somebody has. Has your office looked at the scatterometry data at the Esrael NOAA Geo platform because it's a GIS tool?
Not yet. Can you send me that link? That sounds interesting.
Yes, I can get that link sent to you, yes.
Thank you. That would be great.
So your scripters can look at that.
Yes. So we've got 3 forecasters still in training, and so they are very ready to get their hands dirty with stuff.
Are there any other questions? Okay, well, I'm going to thank Brandon again for the talk. I'll give him belated birthday wishes too.
Thank you. Yeah, it's been a long day. It's been a long night shift and not much nap yesterday.
Yeah.
Busy birthday.
And thank you for listening to this latest FDTD satellite applications webinar.